Hey guys, so now we are going to finally move into making some statistical calculations. Now I'm going to make this a two-part video, and the first part we're going to be introduced to the different statistical measurements, and we're going to define them as well. So we're going to define mode, median, mean, and range. And in doing that, we're also going to look at how to calculate those based on the data set I've been using. And in the second part, we're going to do that. I guess the first part we're going to call the long way. And then in the second part, I'm going to show you where this frequency distribution table is so powerful and how it can make our lives a little bit easier. So, what we're going to do here is we are going to define all of these now. So I have my data set, and underneath it, I'm going to write my mean, median, mode, and range. So let's start with the mode. That's a pretty decent one to start off with. It's not too conceptually difficult, but the mode is just the most occurring number. So the value, the score that appears most in our data set. So we'll look at, so this is the most occurring value. Okay, that one's not too bad. We're going to start with our easier definitions and work our way up. Next, we're going to look at the range. So the range we can think of as the distance between the smallest and the largest value in our set. So when we look at, when we say anything, so you say, for example, oh, I have a range of hobbies or interests. The range is sort of the total scope of what you're talking about. You know, I have a range of books. When I say a range of books, I'm talking about all of the books, kind of how many I have. And similarly in statistics, when we think of the range, we say, well, it's the range of numbers, the kind of values that the numbers span. And the most important values in this context are the smallest and the largest. Sort of what is essentially the distance between smallest and largest. And we can think of this as essentially the difference between the two. So when we think of difference between largest and smallest, the key word there is difference, which implies some type of subtraction. So subtracting the smallest number in our set from the largest gives us the range. It gives us all of the kind of whole numbers from our lowest to our highest value. So the range here is the difference between highest slash the lowest. So we can also look at this as, well, in brackets, we'll write H for highest minus L, which is the lowest. So as I'm saying these things, you may already be subconsciously calculating these in the data set that I've presented. And if you're doing that, that's great. If you want to just listen first and then work through it with me, that's absolutely fine too. Now, moving on, we've defined these two. We have two more to go. So now we're going to look at the median. And the median and the mean are two quite significant ones because they deal with this notion of kind of the center of our data set, sort of around the middle. And we will I'll show you why that is. But the median, which I kind of dropped a bit earlier, is our middle value in our data set. So that is what we get when arranging the data set from lowest to highest, which we did in previous videos, especially when I was constructing the stem and leaf plot. Going from lowest to highest makes it way easier to read. And not only that, it also helps us to identify the middle a little bit easier. It's way easier to locate our number that lies smack bang in the center of our data. So that's quite important, that our median is found only when our data is arranged from lowest to highest. So we actually see this idea, like it's a recurring idea. Even we had here the difference between highest and lowest. So when we talked about the range. So a lot of these things imply that we should look at our data set in some kind of order. We want to order and arrange this data set in a way that goes from smallest to largest. So I'm going to write that in brackets here. So I'm going to write lowest to highest. L for lowest, H for highest. So our median is our middle value when we look at our data from the lowest value to the highest. And finally, we have our mean. So our mean, as we have mentioned before, is our average value. So this is the value that we get when we add up all of our scores. So when we add up all of these numbers and we divide that by the total amount of numbers we have. And the average is good because a lot of the time you definitely would have heard this this term thrown around. If you watch sports like I do, for example, you're watching basketball, they always have a player's average points per game. So an average is a really good measure of the middle. It's the measure of this center. And we, as humans, we like this idea of a middle, which comes from our median and our mean, which are different, and we'll explore that soon. But we like this idea of the middle, kind of on average, the middle of everyone. And we often measure ourselves against this average. You know, if you were to get a test in school, naturally you're going to think, all right, well, where do I stack up in relation to everyone else? Or if if you play sport, you're in a team, well, how many points did I score in relation to, my average, the kind of middle ground of where I'm at? I, for example, had a really good game. Well, that's great because my score was really high in comparison to the average. So this average comes up a lot in life because I think as humans, we always want to measure to something. And this idea of averaging out that we've come up with is a good way to gauge the middle, roughly. So our average value is calculated by summing the scores. So I use this term scores to mean a lot of different things, right? It can be any type of score, right? Any type of value in our data set. So our average value is the sum of our scores divided by the total number of scores we had, the total amount of data points we measured. So in this case, we have 2, 4, 6, 8, 10, 12, 14, 16 data points. So that's what we're going to be dividing by. So we have the sum of all the scores divided by the number of scores. Cool. So here we are. Here are all of our measures, our measurements, and kind of important things to consider when looking at data. So already you may be thinking of different plots that we've done, which may be good for calculating certain things. So let's go through this slowly, for example. For example, our mode, our most occurring value. Can you think of any plots that we've looked at which could tell you this? Now, you may recall back to dot plots or histograms, right? We had these dots or these bars that showed us the frequency of each of our scores. And often the bar that went the highest, or the dot plot, the value that had the most amount of dots, that value had the highest frequency. So we can calculate the mode via a lot of these plots, or just by counting the data. Here we can see, well, I have 4 3s, and that's the most times a number occurs. Our second best is our 3 12s. So if I move over to the side here, when we actually calculate things from our data, we can often just read off it. So our mode, we counted that 3 was the most occurring number. So that is going to be our mode. Now, what about our range? Well, we can identify our smallest and our largest values and then subtract one from the other. What's the highest value in our data set? Well, we have an 18 here, and the smallest is a 3. It doesn't matter how many times these occur, we just want to know what the smallest is, what the largest is. So for our range, we want the largest, and we want to subtract the smallest from it. So we get a range of 15. There's 15 numbers between 3 and 18. Well, 15 whole numbers. So, okay, moving on. Let's look at our median now. So we've got a data set, but it's important for our median now to put these from smallest to largest. And then essentially just count the middle number. Actually, let's find the mean first, because we can find the mean without rearranging these. So let's do that, and feel free to use a calculator or to add all these up beforehand. But I'm going to do it now. So our mean, when we add up all of our values, we get 164. And so we've added everything here together, and we divide that by the we divide that by the amount of numbers we have. And we have 16 numbers here. So we can divide 164 by 16 here. And we're going to get roughly, this is just from a calculator, we're roughly going to get that the mean, the average of all these numbers is about 10.25. About 10 and a quarter. So looking at all of these numbers, well, you can see that probably when we average them out, we have a lot of high numbers, we have a lot of low numbers. So in all of our scores from 0 to 20, in the context of this data set being, for example, scores on a test, the average is around 10.25. So that kind of checks out. That sort of logically checks out a little bit. because when we average everything out, we get something around the middle between 0 and 20. Now, this won't always be the case. It just worked out really nicely for our data set. And finally, we are going to calculate the median, which unfortunately results in us having to write out this data set from smallest to largest. So I'll write that through now. Okay, so I have gone through and just written out all of these numbers from our data set in ascending order. So we essentially just want to locate the middle term here. So out of all of these, we want something kind of smack bang in the middle. So we can kind of just cross off on either side one number as we go. And like I said, this is the longer way to do it so that I can illustrate how we can, so that in a later video, I can illustrate a more efficient way to find this. So we have a total of 16 terms. So we notice that when taking equal, when kind of moving from the outside in, we have 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7 terms on either side. So that means the 8th and the 9th term in this case are our middle terms. Now, you'll notice when you work through certain questions that when you get an even number of numbers within your data set, you will get 2 medians. And when you have an odd number, you'll get 1. Now, you can play around with this, but obviously, I guess it's kind of, not obviously, but intuitively, this should make sense because an odd number will have a middle number with two equal sets of numbers on either side, which will make an even number. And this even number, in addition to the number in the middle, will make an odd number. So any even number, when you add one number to it, you get an odd one. So for our odd numbered data sets, we would expect just one median, so it's easier. But in this case, I've included an even one. So we get 2 medians. Now, this isn't too bad because these two numbers are the same, but often what we do when we have 2 medians, meds for medians for short, well, we want to find the middle of these two. And a useful tool for this is averaging out. Because that was another way of, well, just taking the average of these two numbers, that's roughly going to be the middle. And we can do this by adding our 2 medians and dividing them by 2. Sorry, that one looks pretty shocking. Let me redo that. Now, in this case, it's quite easy because these are the same numbers. So 12 plus 12, we get 24. Divided by 2, we get 12 again. So if your 2 medians are the same, then taking the average is just going to give you that exact number, right? But say we had a 12 and a 13. Adding those and dividing it by 2, we get 12.5 as a median, which makes sense because 12.5 is in between 12 and 13. It is the average of those two numbers. So I know I've said a lot in this video, but we're going to revise these concepts in the next video. And you'll notice that it'll be a lot easier to work through once we have our frequency distribution table. It's a pain to set up and do the calculations, but you'll notice that once you have it there, it's way easier to work with. So this part of the video was what I like to call the long way. And once we get our table in the mix, we will look at the short way. But so far, we've been able to use these definitions on the left-hand side, and we have been able to, with our data set in question, calculate the mode, range, mean, and median of this data set. And this is all for the purpose of starting to understand our data, right? Especially with mean and median. We're seeing kind of roughly where the middle ground is for all of our scores. So I'll see you in the next video, and we'll move on to calculating these exact same things, just using our frequency table that I drew up in the last video. See you then.